Here are these elbows. We are talking about any size. These are 90 degrees. We know that it is 90 degrees. That's all it knows. I'll be honest. That at home I don't have a right angle or anything with which we would know this very well. Watch. So these elbows, these are factory conditions. According to, let's say that they know almost 90 degrees. That's why it has a standard deviation from 88 to 91, but usually 88 to 89 degrees they used to be. The problem is, isn't it? Not always 90 degrees the pipelines turn. And they tell us to cut one out of this any degree. How will we know? Cut off this arbitrary degree? Let's take a quick look. I don't have any at home right now. I have a measuring tape. About the tape measure. We already know that in one direction bends relatively well. In the other direction, don't let yourself because he won't like it. We know that the elbow is 90 degrees. I'm searching for something with which we can draw. So we draw it like this, that here is our elbow. That way, we know that it can thus be 90 degrees. It's 90 degrees here. And now, if we want to cut any degree from this, let saw machine and others are not. Us cut 32 degrees. So his methodology is whole elbow that on the outer radius. So this to the perimeter length we want to measure we need it once. Such a size you need it on an inner radius measured size. So we need this is what we need. These two dimensions must be measured. I usually get along with myself. Carry a paper tape measure, IKEA OB Bauhaus, meters long, the same on paper, which can be wrapped very well, but if that's the case, then you will, and that's the point where are you driving so you push it in. You can see if possible. You measure 1 in the center of the axis. Radius, at the outer side, you can do it like this if possible. Here's the problem. That no matter how tense you are, they will be at the tape measure inequalities. It won't be a perfect size. But in this case, 99% of the time, that's pretty accurate. To be good. Now, if you measured, have your size, any. So it applies to any. The point is that there will be an exterior, there will be an internal one. If you really can't measure it, that you only have solos, then just go for it. Can be translated 1 or 1 also a sheet of paper, you mark it. You spread it straight, have the size. Good. So we got them now. Our size. I will not be specific here. Write down the size. There will be one X, the other will be Y. This is for 90 degrees, right? So we know that it is below 90 degrees. This is the size for us. You don't have to overthink it. Divide by 90 degrees. What is happening? If divided by 90, then we get the 1 degree value, and you multiply that, right? To the extent. As much as you want to get. It doesn't really matter. It can be 30, 40, 50, 22, 16.5. It doesn't really matter. So it's not the end of the world. Simple. Once we get the values, if we got the value. So now it will be like that for us. Look like we have our X that you have the 90th part, right? And multiply it by 32 too. Then we will get same for Y, and multiply by 32, and then we get it the value that if you survey the perimeter, on the radius, elbow. You measure on the radius, then it must be marked there. And then you will get that a size that is important to you. Doesn't that mean? As measured by. The same with the methodology in general. You don't hang up the end, but if possible. Then you set it to 10 cm, and then you can measure from there. No problem. If you need help, you take it. Someone marks it. For a given size, so you will have a mark. On the inner radius, you will have a mark A on outer radius. I have these two signs. This is basically what you need. To happiness, and from now on it is important. These two signs together. You have to mark. Or with string, or with welding wire. The welder thin welding wire is best. You bend it, that's the important thing. That, right, as you have the patent bow, the string, and the welding puller, you can make it so. To turn it around. So, if you want to be very precise. To be and how well. It should be clearly marked. Then you could polish it here on some flat surface. Or get a line here, could you also mark it here the other side too? And then it wouldn't go away, would it? There is one soon. For me, so you grab this string. It will not have simplicity. There's your sign, here's your sign, you put it on, you mark it. Now the problem or that mistake can be made when the sign is there. But we say between the sign it can still be. The string can still stop. And then you get one afterwards nice cut. No, that's all a little creativity. It takes so many eyes that you set this up nicely. So run smoothly. And then you mark it off. You drag along, you mark along. Other side flips, other side the same. You tick it off nicely. And you can tell along the marking to cut. What is important? It is important that if you look, we are looking for something, which is a straight and flat surface. For us, oh, what have I found? Which is a straight and flat surface. Us, so the books those we use it, the important thing is that a factory cut. Because it's above everywhere, so if it suits you, and you cut it right, then it's your cut surface, right? will also sit up everywhere. If there is one less good cut, let's say it's one less good cut, I don't know how it looks. Here it will sway. There will be a gap. But let's say even this is all livable compared to, aha, you can see it here. We put some light there. You can see there that it doesn't sit up anymore. Everywhere, it's already gaping. So it's going to rock. In this compilation, have to play. So that's about it. That's all you need to know. This is the point of the whole tour. You measure, once again. Outer radius, inner radius, refers to 90 degrees, of which, to get that 1 degree, divided RAIN by 90 and the received value, you multiply preferably with a nail, just the right number of degrees to cut for you. You need it, that's the point. It is completely independent of diameter. It does not matter, that 1 inch, 160, or an 80 or A100 or A500, or a patent of 600. You cut, it will be the same method, numbers will vary.